Hello students! Welcome to today's lesson where we will start understanding the fascinating world of collecting data in statistics. This is an essential skill for understanding what is happening in various aspects of our lives and has uses from politics to farming. Our goal today will be to understand how to collect this data, learn some key statistical terms, and recognize what can lead to biased data. The plan for today's lesson is as follows. First, we will explore what kinds of data we are interested in and why it's important. Next, we'll define some important terms. We'll start with understanding what populations and samples are. Finally, we'll talk about bias and how to avoid it. By the end of this lesson, you'll understand the importance of data collection, the role of populations and samples in statistics, and how to avoid biased data. Let's get started on this journey into the world of statistics. Let's dive into the main concepts of today's lesson. First, it's important to understand what kinds of data we might be interested in and why collecting this data is so crucial. Data helps us make informed decisions. For example, a politician might want to know the income levels of constituents to determine how many are living in relative poverty. This type of data can influence policy decisions and resource allocation. Understanding the data allows us to see patterns and trends that might not be obvious at first glance. The first known census happened in Babylon over 6,000 years ago. Ancient civilizations like the Babylonians collected data on their people, animals, and goods to manage their resources better. By counting and recording this information, they could plan for things like food supplies, taxes, and even military needs. This early data collection was an important step in the development of organized societies and laid the foundation for the statistical methods we use today. Next, let's define some key terms in statistics, starting with the concept of a population. A population is the entire set of similar items or individuals that we want to study. For instance, if we want to know the percentage of UK residents who believe the government is doing a good job, our population would be all UK residents. Other examples of populations could include all the entrepreneurs in a country for a business study, or all the cows on a particular farm for agricultural research. Studying an entire population is often impractical due to time, cost, and logistical constraints. This is where the concept of a sample comes in. A sample is a smaller subset of the population that is selected for the actual study. The goal of the sample is to accurately reflect the properties of the population. For example, instead of surveying every resident in a city, a politician might survey just 2,000 or 3,000 people. A well-chosen sample can provide insights that are representative of the entire population without the need to gather data from everyone. Now, it's crucial to discuss the importance of choosing a good sampling method to avoid biased data. Bias can occur if the sample does not accurately represent the population. For instance, if a politician only surveys people from a wealthy neighborhood, the data collected will not accurately reflect the views of the entire city. This could lead to skewed results and poor decision-making. Therefore, it's important to use random sampling methods where every member of the population has an equal chance of being selected. This helps ensure that the sample is representative of the population, leading to more reliable and valid results. By understanding what data we are interested in, the role of populations and samples, and how to avoid biased data, we lay the groundwork for effective data collection in statistics. This knowledge is essential for making informed decisions based on accurate and reliable data. Let's look at some more examples of sampling. We'll start with a simple example to apply the concepts we've learned about collecting data and avoiding bias. Imagine a school wants to find out the average number of hours students spend on homework each week. The population here is all the students in the school. Since surveying every student is impractical, we decide to take a sample. To avoid biased data, we need a sample that accurately represents the entire student body. Instead of just asking students from the top-performing classes, which could skew the results, we use a process called random sampling. We could, for instance, randomly select students from each year group to get a diverse and representative sample. Once we have our sample, we ask each student in the sample how many hours they spend on homework each week, then calculate the average. This average should give us a good estimate of the homework habits of the entire student population. Let's consider another scenario. A company wants to know how satisfied its employees are with their working conditions. The population in this case is all the employees at the company. To get an accurate picture without surveying everyone, we take a sample. To avoid bias, we ensure that the sample includes employees from different departments, job roles, and experience levels. This way, the sample reflects the diversity of the entire workforce. We then conduct a survey asking about various aspects of job satisfaction. By analyzing the responses, we can draw conclusions about the overall job satisfaction at the company based on our representative sample. Let's consider a final example. Suppose a city council wants to understand the transportation habits of its residents. The population here is all of the residents of the city. We need to collect data from a sample that accurately represents the population. To avoid bias, we must ensure that our sample includes people from different neighborhoods, age groups, and income levels. If we only survey people at a busy downtown bus stop, we might get biased data that overrepresents public transport users. By using random sampling methods, such as sending surveys to randomly selected households across the city, we gather data on how people commute. This information can then be used to make informed decisions about transportation planning and infrastructure development. In all these walkthroughs, we practiced how to collect data wisely, select representative samples, and avoid bias to ensure our findings are reliable and informative. Keep practicing these skills with different scenarios to solidify your understanding. In today's lesson, we delved into the essential concepts of collecting data in statistics. We began by understanding the importance of data and how it helps us make informed decisions by revealing patterns and trends. We then defined key statistical terms, starting with the concept of a population, which refers to the entire set of similar items or individuals we aim to study. We discussed how studying an entire population is often impractical, leading to the use of a sample, which is a smaller subset that aims to accurately reflect the relevant properties of the population. We highlighted the significance of choosing a good sampling method to avoid biased data, which can occur if the sample does not accurately represent the population, leading to skewed results and poor decision-making. To mitigate this, we emphasized the importance of random sampling methods, where every member of the population has an equal chance of being selected, ensuring the sample is representative and the results are more reliable and valid. We have laid a solid foundation for effective data collection in statistics. This knowledge is crucial for making informed decisions based on accurate and reliable data.